At least I think so.
Hello,
Yay!
everybody.
It's like I think I clicked the right buttons this time. Here, let me make this the whole
Hi,
screen.
Janelle. Hi, Les.
Yeah,
Hi, Heidi. Hi, Margaret.
yeah. Hi everybody. We
Sorry if
got
I missed anyone.
yeah, we have some fun to talk about today. We have an angry little sunspot that emerged and started screaming. In fact, it's still screaming. But but it hasn't really given us anything kind of crazy to talk about Aurora wise. I mean, well, we have one geomagnetic storm watch up for a glancing blow, um, which we'll get into. But it's quite a fun little sunspot. It really is. We were just getting the videos. Oh, it's hype scale. Yeah, we're definitely at H5 because people were talking about it being Carrington power, whatever the heck that means.
So here's the thing with I found with the hype scale is that it's either at 0 or 5. There is no in
Yeah,
between.
there kind of is no little in between. You're right on that. It's all of it. It's either none of it or all of it.
Yep.
And we're at all of it right now, full throttle.
Yep.
Um,
Oh God, yes.
but we'll get into this because it is a fascinating sunspot from a scientific perspective. So we'll talk about it, but I'll let Tanya, of course, take the reins on sharing stuff, so I don't press the wrong buttons.
And I am finishing the slides as we speak, so that's gonna be lots of fun.
That's
All
fine.
right.
I can start with videos if you want
Yeah,
instead.
we want to do that.
I could definitely start. I
Okay.
Okay.
am I am good. I just need to start sharing. So let me do this.
Yeah, like Janelle says, it's having a lot of fun by itself. It is.
Yes, it does. So, we gonna talk about this region, but before we get to the kind of the core of it, we do have an update. There is actually a backup to ACE. So we
I know.
have three spacecrafts that are transmitting solar wind data back to Earth from L1, and that's IMAP, which is
Mhm.
NASA's mission. But the data is available, I think, as of February 1st.
Mhm.
And IMAP data is already integrated into Glendale app. So thank you, Andy, for doing all this work. We will likely see a lot fewer gaps in solar wind data,
Woohoo!
and I know this is super exciting. This is super exciting because I am just tired of all the gaps and having no information about what solar wind is doing. So it's both magnetic field and, most importantly, more reliable plasma measurements compared to Discover. We are still waiting for Solar One data to arrive, and hopefully that's going to be sometime in the spring. It's definitely in the right position, but we don't know when data is going to be available. So this is exciting, and if you don't know the Glendale app, it's about time to upload it and install it and start working with it. It is a backup to currently existing systems. So if ACE is available, that's still a primary. If Discover is available for magnetic field, it's going to be sort of secondary. If ACE is not available, if neither spacecrafts are available, it's going to be IMAP. So it's sort of a double redundant system, which is actually pretty cool.
I
So
agree.
again, thank you, Glendale. Thank you, Andy. This is awesome.
Yes.
So I don't think this is even current. So this is as of earlier this morning, and we have quite a few coronal holes and a few active regions on the map. Of course, we're going to talk about this one.
That's why it's in red.
But there are a few coronal holes, and I think they are kind of changing too because we have an active region and other regions, and we've got a coronal hole that is soon to become geoeffective, and it may play into what the recent CME has done or will do potentially. But this coronal hole is complex, so there are a couple of spots probably here. And part of it may be hiding under the loops. So loops don't go over coronal hole, but at the same time, they can obscure it depending on where coronal hole bounds are and where the loops can be magnetically positioned. Because again, coronal holes
Mhm.
do have pretty strong magnetic field, and CMEs don't like traveling over it, and coronal loops don't really like to hang over it. but it really depends on sort of balance between where different structures are. There is a kernel loop, kernel hole here, and there is a kernel hole here. All of that plays into what active region will be doing here in terms of CME. So we will see a fairly complex pattern of deflections, which actually was the case with X8 flare CME. All of them are negative polarity, because positive polarity right now is on the opposite side. But again, it's all a deflection risk, and we're probably going to see CIR from this structure wherever it is because it's
Yeah,
partially obscured.
it's kind of buried in there.
Yeah, yeah, it's there.
Yeah.
You could see it when the loops start to shift a little bit and something is going on. This has been sort of the busy day for, well, busy, what, 3 days since the
Yeah.
region emerged. And you can see where things started. It just ramped up and it keeps on going, and it really hasn't changed that much. It's still fairly active, although the level is starting to decline, and we're going to talk about why it's happening. As any self-respecting region, it continues to evolve and tries to makes itself a little bit more stable, and we're going to see it in terms of what flux is doing, of course. So this is just what it does in X-rays. It does a lot of other things in all the radio frequencies. It is definitely a strain for high frequency and very high frequency communications. So our emergency responders are really not having fun right now, having to communicate, and ham radio community is really not very happy on the day side with this active region because it keeps on singing
Yeah, it's
very,
I
very
can't imagine
loudly.
we've had much high frequency propagation in the last 24 hours at this point, or 48 even.
Yeah.
It wants to be heard.
Yes, it
And
declares
only
itself.
it, nothing more.
No. But yeah, it's been busy. All of those flares, I think above M level, they have to be entered manually into Donkey. So
Saw Karina
uh
doing that for a while.
yes,
Look
I
at how
know.
many.
Yes. Karina, we love you and we appreciate the work you do and all the work done by M2M and forecasters everywhere. This is a busy week for you, and all of the flaring and watching what Sun is doing. That's got to be
Yeah,
pretty tiring.
don't we have a moon mission coming up real soon too?
Not
Oh,
for February.
Okay.
yeah, no, not for
They
this.
pushed it
This
back.
is,
Okay.
yep, yep. I think.
Otherwise, yeah, it would have been in a few days.
Yeah, it's like, oh,
Ooh,
good time for yeah, maybe it's good
yeah,
to
just in
go.
time for that active region to actually do something and launch a
I'm not
massive.
actually sure why they postponed it. It could be solar activity related, though.
Yeah.
Yeah, I think that very well could be. So, but yeah, it's been busy. So,
Is this your video? Yep. Looks like it is.
yeah.
Look at this
So,
thing.
and now this is the version. I did some high def work on this one too, so it should look. Actually, yeah, that looks pretty good from here. But basically, it just highlights the actual structures a bit more. So, what I want to make out the point here is this is the tracking model for the sunspot. This is the magnetogram over top. Red is positive, blue is negative. I want to emphasize that this is arbitrarily defined color-wise. It can be any color for any polarity. It doesn't matter. I know that the HMI instrument on SDO on the website has red as negative and blue as positive. It's an unfortunate swap, but when I use the PFSS, I like using the same colors. So blue has always been negative and red's always been positive there. But the idea is look how complex it is, at least on here. Now, and go ahead and have it stop there. And I'm going to share my screen here for just a second because
Yep.
this is only up to.
Oh, hold on.
When did that video stop? I want to say I did it for this morning.
Mm-hmm.
So at this point, it has changed
Oh, I think
significantly.
if you want to,
Can I
it
share
won't,
over top? Does that work?
yeah,
We got a sharing fight.
yeah. Just kick me out.
That's fine, as long as mine's coming through at this point.
Yeah.
But so this is the region as of just a few hours ago. I want to say 6:30 roughly. Here we go.
I think I'm still sharing.
I see his helio viewer.
Well, let's see.
What does it
YouTube.
say?
Yeah, it looks like I'm up. Cool.
Okay.
YouTube shows this too. So this is the spot
All right.
now. And the important thing here is this was during the X1 flare that the last one we had, not the one this morning, but the last one there. Look at the complexity in here. We had so much shearing. We've got a positive umber here, negative umber here. It's all sandwiched together. This is now. It has changed and simplified immensely. We don't have much of a middle section here. In fact, a lot of the polarity itself has kind of sunk away, so it's no longer one giant magnetic island. It's just kind of three separate parts, still an active region on its own. A lot of the positive umbras that were around, at least in the middle section of the sunspot, has since merged and become one giant umbra here. This isn't to say that just because it's merging and separating, it's going to completely get weakened. But we do still need that shear and some sort of tension to provide the energy to then hope for a good CME and a good flare. Whereas right now we don't have a lot. So this central region still looks pretty good. It's kind of mixed in, but my thoughts are these positive umbers are going to kind of dissipate from here. This is probably going to disappear or at least merge back into this one. And then we'll have the negative side start forming up here. But this delta region is still looking pretty primed for some good action. It's sandwiched pretty heavily in between two negative areas. And generally, it's trying to move south. Well, we've got a lot of issues with it trying to move south with all the negative stuff around here. So I have some hope still. I do want to reveal the PFSS as well. I like these to just kind of see the general, this is just a model layout of the photospheric magnetic field. White is closed lines. So these are magnetic field lines that will close ultimately on the sun somewhere. And blue is then negative polarity, but open field lines. If we go back to, what was that, the first? It was like midnight on the 2nd, I believe.
Yeah.
Something like that.
Mm-hmm.
So about right here, we'll say. We had the CME, but we noticed it had more of a northeast trajectory from that. This is kind of a good hint as to why. It had some plenty open magnetic field lines to follow through to get out of the corona once that launched. But these closed structures didn't really allow for much, especially given that yes, it was a bright flare, it didn't really have that much energy associated with it. So it doesn't seem to have changed too much, at least. And now, again, I don't trust the PFSS as a fact, but it does still have a general layout the same. There's still a closed structure all to the west of it, and there's still an open structure heading to the east of it. So if there's any eruption right now, unless it's super strong, will likely just get fed along those magnetic field lines outside. So that's what we're looking at with the sunspot region. I haven't been concerned with this region too much. It grew pretty quickly. It was nice to see all those high flares. It was nice to see an X8. I'm not thinking it's going to be anything monumental. I don't think we're going to get anything serious from it. I am trying to jinx myself purposefully, however.
Yeah, so
but I legitimately don't think it's going to. God, no. So if people... nope, we're doing this. Forget it. Carrington associations, stop that. Carrington spot. It's a big size, and that doesn't mean anything. It never will mean anything. The size of a sunspot has very little to do with its actual ability to produce something magnificent. I've seen smaller sunspots, especially, that have done more as far as energy and CME release than any of the bigger ones. So please stop comparing things that aren't really comparable. It's kind of annoying.
Okay, and back to the slides we go.
I do have a couple other videos of the eruptions too. I put together, I want to say 304, 131, and 211, I think, for the corona.
I think this is what next video is.
Yeah.
If I'm not mistaken.
Yeah, so the X81. And basically just to see, so you see all the material eject to the northeast, you see it kind of get pushed back to the south too, from that coronal hole to the northeast of it. Little short, but you also see how there's no real material being shot to the west. Well, we got the closed lines going in that direction and the open field lines going to the east, so it makes sense that it's coming that way. Ultimately, pretty flare, but I'm not really thinking that CME was much. And then we had another one. Now, I don't know if you want to do the next slide or not, but we can watch this one more time.
Oh, yay. That's the same one.
Sorry. I meant that one.
Okay.
This is the X1 flare from yesterday.
Hold on. Yeah. Okay.
I like this one a lot because you can see that it's just reconfiguring. The coronal loops are changing and moving around. Yes, it gets bright. That was the peak of the flare. You could almost not even notice. We got some P's there as well, but it's just mostly reconfiguring the loops and moving around. It's pretty evident that there was no eruption or why there was no eruption. There's just no energy to it. It's reconfiguring to a lower potential, and that's where it will stay for the moment. I know there was a flare as well that I didn't get the video for, but
I think most of the flares have been that. It's sort of reconfiguring event without much of the material
so
that,
that's why I was like, I'll just keep that other one because that
yeah,
basically gets the
exactly.
idea.
Exactly. So that was really kind of bouncy CME almost because the kernel holes, there are quite a few kernel holes that are framing this region, which results in really, really, really strange LASCO pictures. So this is a chronograph. There was actually some material that was heading in this direction, which is really hard to see, but this is what we got in stereo. So some of the material was traveling a lot faster, and that produced a really odd shape
Very
CME.
narrow and stretched, it looks like. Ugh.
Shock was, I think, fairly wide, so there is a chance that we might be getting something. And again, it bounced around and got deflected, sort of almost northwest, and probably some of it got deflected more centrally, but it's really hard to see. So
Mm-hmm.
there's probably something traveling in our direction. And I would have to say now we have certainty in that because, again, all the modeling was done, and you can see disagreement between even M2M models because this is for lower speed. So this is the part of CME that was measured at 267 kilometers per second, and
Ugh.
it's going, yeah, it's kind of going to the east of us and mostly going north. This is slightly higher speed and a slightly different trajectory, but again, those are the two scenarios. Both of them are actually plausible. So if I have to assign the probabilities to each one of them, I would have to tell you I have no idea. Both events are very much possible. Just take it and um, watch what happens because we really have no way until it shows up at L1 to see what it's going to do, except, again, we have a bit of a solution here. This is Space Weather Prediction Center. I think they're trying to really push it out a little further. So it's sort of late February 5th where they're putting it. I think this is more of a CIR picture that they're putting there. So more of overlap and how exactly it's going to come and what's going to strengthen or sort of dissipate what we really don't have a clue. It is going into fast solar wind, if anything. So how it's going to show up is anybody's guess, and obviously it's not going to distort CIR in this way. It just doesn't happen. It's not going to fracture another magnetic structure. Again, Met Office modeling, also putting it into sort of late February 5th, into February 6th, or maybe potentially nothing at all. So some of those runs resulted in no impact, which is why you see sort of continuous line. And this is also a possibility. So Hawks finally about 70% of runs resulted in hits, and you see a pretty wide window of arrival. So that happens when the uncertainty is very high. Speed, anything, but not super crazy, probably closer to 500, what it is showing for speed at the time of arrival. So 440, 442. So not the super fast traveling CME by any means. And you probably would expect more from X8 flare because it's pretty energetic flare, but that was not the case. So the class of flare does not equal faster traveling CME. It can, but not always. Don't assume until it's measured. Don't assume until you see it in LASCO. Forecast summary based on this so far is really high uncertainty in arrival because of location. It's still in it happened in location that is not at the central meridian. It's still decent. So for higher energy and for faster traveling CME, you could probably say that, yeah, something could happen, but it was narrow. It's flanked by several coronal holes, and it resulted in fairly narrow CME. It got deflections all over the place, it sort of bounced around until it finally got out, cleared the view. High uncertainty in terms of timing of arrival, because again, it's a complex event. It got twisted and sort of flopped around a little bit. Speed estimate disagreed. You have two different measures and two different models from M2M alone. I think everybody else tried to make several runs, and I think you could see it from Met Office where some of the runs really resulted in no hit at all. High uncertainty of impact and because of unknown magnetic structure and overlap with CIR from a coronal hole. So as of this morning, this was my summary. Things have changed because we have a
Just in the
solar
night.
orbiter. We have a solar orbiter that is our sort of advanced warning system at this time. It is already west of Sun-Earth line, so it's separated by about 15 degrees, which is not great for predicting CME arrivals, and it's only 2 degrees south. But that 15 degrees separation to the west, if that CME manages to appear so far west, being launched in the eastern hemisphere and going into Western Hemisphere, you have a lot higher certainty that it's going to hit Earth. It's really hard to bypass Sun-Earth line from Eastern Hemisphere traveling to Western Hemisphere, where Solar Orbiter is right now. So higher certainty in arrival. It had a pretty decent agreement with M2M modeling for speed that was over 500. So the predicted arrival, I think, was actually about 1800. It arrived slightly earlier. So we're still looking at likely arrival at Earth late February 4th to early February 5th. Impact is still at high uncertainty because we don't know magnetic structure. This is starting to look sort of like not that great of an impact. So 30 degrees nanotesla at roughly zero 0.6 AU. So it's not quite half the distance between Sun and Earth, but it's kind of getting there. So you really want higher strength there because CMEs lose a lot of power by the time they reach Earth from
This is
that
just a
location.
general number, but if you do the inverse square law, so we do half the distance to where we are, we're looking at about a 1/4 reduction in what the CME strength would be on our end. So 30 nanotesla, divide that by four. I mean, we're basically looking at your usual 8, 9 nanotesla, like a bump. It won't be quite that low, but it's not going to be that strong either.
And it is looking like a glancing blow. So there might be a little bit of a flux rope that's already showing up there. So that transition is likely a flux rope. So again, it's losing strength. So this is likely the sheath of it. It's pretty, it's oscillating, so there's no consistency, but then you have a transition and there's possibly something going on. It's starting with a northern field and eastern field. How it's going to play out at Earth, because again, the solar orbiter could be seeing a very different part of this CME. If it is a flux rope, which again, we need more data for this, I wouldn't necessarily translate what you see here into what we're going to see at Earth. We still have to wait and see when it shows up, but it looks like it will actually show up, which is pretty interesting.
Right.
Okay. Yeah.
Yeah.
So there is a lot of talk about caged eruptions for this CME. For this region. And when you look, I don't know, Christian, if you want to pull 171, a video of like just 48 hours, it is a sparkler. And all it's doing is just reconnecting. And there is so much reconnection going on, and it happens in such a rapid sequence. There's probably not a whole lot of material that's building up that would be sufficient for eruption. So it's not necessarily a caged eruption or caged flares or caged CME. There's probably not a whole lot of things to cage to erupt. Everything is just being reconfigured as things are emerging. Of course, it may change over time, but again, not every flare will result in the CME, even though the process is similar. They are related, they're not the same. And what exactly leads to a CME from a flare from the active region, I think that's still emerging science, and science is still trying to answer that question, how exactly things happen and how exactly things erupt. In either case, those reconfigurations and reconnections and even the launch of CME, all of that works toward simplifying the region and really trying to reduce the twist in magnetic structure of the sun. So how sun's going to decide to do it, either it's going to be just flares and no CME, or it's going to be CMEs and flares from active regions, or it's going to be a filament that's launched. Doesn't really matter. Sun doesn't care. We do, because we get to see Aurora if there is actually a pretty big core of the CME with the twisted magnetic field that comes our way. So we would like that. I'm sure infrastructure would hate us for that, and hate the sun, but that's what we would like to see. So flares, not so great for communications, but not really a sign that something's going to happen. It's not flare equals CME.
Yes.
And it never will be.
Ooh.
So always look.
Yeah, exactly. But it is a clickbait region, because every time it flares, everybody just goes and looks at the video. Is there a CME? Is there a CME? Unfortunately,
yeah, I have now
for
muted
this one,
even our 3 blackouts at this point.
Yeah, unfortunately, with this active region, even X flare is not a guarantee of the CME.
Nope. I do have that video up and ready if we want to glance at it.
Right.
Sure. You may have to boot me out again.
Oh,
I
I'm
gotcha.
not sure what it's doing.
I gotta kick you out.
Yay, please do.
So this is from the first 2300, so right
Hold
before
on.
the X8 flare
There we
to
go.
the third, which is the third 1400, so earlier this morning, essentially. And it's just a 10-minute cadence, so it's not like I'm getting every single frame on here, but yeah, you can see how often it's glowing and flicking, and the arcs will change, and they'll move direction, and then they flare again and move. It's just constantly reconfiguring.
Yeah, that's pretty
And that was
wild.
the last of it.
Look at
Like,
it
it's
go.
not consistent for a single second there.
It needs a break.
It's angry, that's for sure.
Yep.
But angry in the wrong way for us. It's just a paparazzi bulb.
Yep.
So
H5.
okay, now we can go back to the slideshow.
But yeah, that region. So while that region has been busy reconfiguring itself, social media has been busy scaring people.
Yeah,
I would have to say,
making bad claims.
Probably sometimes a little bit too effectively. But again, every time there's active region and flaring region on visible disk, people start to compare it to Carrington, in Carrington Sunspot and Carrington event. Is there a risk of something big coming from this region? There is always a risk. Have we seen any evidence that it's going to do that? No, not really. So even X8 flare resulted in pretty wimpy CME, all things considering.
Yep.
And this is not to scale. So this is really not accurate representation of what Carrington Sunspot was and what this Sunspot is. They're not the same size. They're not the same complexity. So please do not try to argue with if you see those posts, because it just drives engagement, unfortunately, for them. Just report them as false information, because that's what it is.
That's my favorite thing to do. Just let an innocent group or something putting up and like, all right, report for inaccurate info and block. Yeah, if you see a Carrington comparison and it's nothing but this is not a Carrington event / Sunspot, they are just looking for hype. They're not worth following.
They're not worth following. They're also not worth arguing with or correcting, because unfortunately you start to interact with them, it actually pushes that post all to all of your friends.
Yeah, it does.
Because it increases engagement. So it must be important if you are paying attention to it. So all your friends will do the same. They will get the same information. And there are people who may not necessarily follow space weather, but they're really looking at social media. So they might get scared because, again, inaccurate information and hype, this is how those accounts drive engagement. This is what they do. They thrive on fear. They thrive on people clicking and saying, "Oh my God, this is crazy. This is so dangerous." But this is really this region has not demonstrated any signs of significant threat, short of just throwing sparks all over the place. So it's kind of cool to monitor. It's cool to see, but is it dangerous for us? We haven't seen signs of it yet.
If we start getting R5 blackouts, I'll
Yeah,
change my tone.
Yeah.
I'll be more worried.
I've never seen an R4 blackout in 14 years, just for the record.
So the chitter
It was the
chatter.
wrong solar cycle.
Yeah. So we might
Yep,
as well
I needed to
mention
be
it.
on cycle 23. Damn.
Yeah.
The other CME looks like they modeled from the X2.58, according to
Which then
Janelle in the
overlaps,
chat.
it said. Yeah.
Mhm.
Yeah.
Yep.
So that's not super shocking because this thing's been busy all day, so they're gonna keep updating models accordingly.
Yep, for sure. So are we going to see more interesting regions in the next year to year and a half? It's quite possible.
Mhm.
We're kind of in that phase of descending phase of the solar cycle where really complex regions start to emerge and they do the usual complex region kind of things, meaning they do flare quite a bit and sometimes they do launch a CME. This one is kind of simplifying itself through flares mostly, not CMEs. So I don't know. It still holds a promise for something for us. And now, of course, it's approaching the Sun Earth line and it's better aligned to launch something our way. Hopefully
Which
it
means it
will.
won't. Sorry. I will always follow the pessimistic/realistic viewpoint.
That's why you're here.
That's fair. Yep.
Got to be that counter to all the optimism. You're the nihilist of the group.
The what is it? The blowhard.
The blowhard. I haven't heard that term in a while.
I know, right?
That's all right. Here, do I need to kick you out again, Tanya?
Yes, you do.
Okay.
I'm not sure what's going on with my Zoom today.
That's okay.
Yeah,
I can
thank
kick
you.
out. But yeah, I mean, that's pretty much it for what we had to talk about on this Sunspot. But yeah. I mean, like I said, it still holds promise. It's not like just because it's simplifying doesn't mean it's simple right now. So it still harbors the ability to do something, but it's oh yeah, we didn't talk about how we were gonna talk about it, so we talk about now how the floor is the flux of X floor or whatever X-ray flux is dropping. So
yes, and that's which I believe from the simplification of the Sunspot group, it's spreading out further now. It's less shear and less tension involved, so it's able to simplify more, which means less energy, which means less bright.
Yeah.
So that X-ray flux will come down with it.
So anyway, but we'll see. We'll see.
It might build up to CME, but
yeah. I mean, and they can always change to the point where they then look nothing like they were before, and they change entirely how they act. Seen that plenty of times. It's you can't really forecast more than like, okay, this area of the sunspot's going to move slightly over here in the next several hours. That's basically as far as you can go with figuring out where these sunspots are going to go.
Mm-hmm.
And I will add, because Les reminded me, because it is full moon week anyway for us people that are in the middle latitudes. It's like we need the big stuff to make it interesting.
Yep.
But
and I'm spoiled anyway, so if it's not like G5 worthy, then I don't care anymore.
And of course we have coronal holes that are definitely on the disk. They're smaller because there are more active regions on the disk right now, so they are getting squeezed and they will come back.
Yeah, and we're getting closer to the solstice again, so now we're yeah, it's all good things. I'm not going to be
Your equinox.
I'm not going to be all pessimistic about it. We have things.
I'll be that for you. That's fine.
So anyway, if anybody doesn't have any other questions, we can let you have your evening back. But we wanted to get a little stream out. I know it's a couple days later. We usually do it, but all this travel in and out that I've been doing, so this worked out for the three of us to do it on a Tuesday.
Yep.
It's not Taco Tuesday. I can't think of a T word for solar flare. I was trying to make it funny, but it's not funny.
Wow, I don't even have complex words.
I don't have it.
No.
They can't use Tesla. No.
Nope.
Nothing works. Anyway, I tried. So let's see. Yeah. Yeah, because
Yeah, we'll have a better idea of what's happening for at least North America tomorrow night
Mhm.
because we might actually see something in solar wind data. I don't know if we're going to have their usual EPAM chase that's going to be particularly productive because this is not a very fast traveling CME, so
Right. Yeah.
I really do not expect a whole lot of things to show up.
Yeah. Won't be
And right
driving
now
too much.
it's a flat line, so it's really not doing anything.
It's just gonna show up
No.
like a little breeze. Like.
Yeah, pretty much. We might get part of the flux rope, given that Solar Orbiter saw something, but
Yeah.
that remains to be seen. I'm I'm not too crazy about this. We'll
No.
see something. We'll
It's
see
just
something. I think that's fair.
it's just fun to watch. So anyway,
Mhm.
you guys, as always, thanks for being here and thanks for listening and tuning in. And then we'll figure out whatever we do next week. We always say we're gonna do. That's what we just gotta do every week. We say that we're gonna cover a topic, and then the sun gets busy.
And the topics are the secondary. We can get to them if it's something we're just trying to stream for, but
Yeah.
I'd rather report sun stuff anyway.
Yeah, well,
So.
this is fun.
Yeah.
Yeah, it is. All right. Well, you guys have a lovely evening.